Hey folks, George Leoniak. I'm going to do another video on the Krystal Spiral, and yes, it's hopefully a quick video. I just made some new discoveries that I'm pretty excited about. So a little while ago, I posted a video on how to draw the Krystal Spiral, and check that one out because in that it will help you kind of understand a little bit where I'm going with this one. But I found now that the Krystal Spiral will just continue to produce an infinite amount of phi ratios within it. So, this may be a little controversial to some people who are into the Krystal Spiral and some of the connection and relationship to at least the Fibonacci sequence and the phi ratio. But within the drawing that I did previously, I discovered where the phi ratio was. So I'm going to continue on with that and show how it will produce this infinite amount of phi ratios within it in a very simple way. So let me share the screen and show you where I'm going with this. So here is the Krystal Spiral, the blue spiral in the center here. And, I'm going to have to deal with a little bit more of the math and the numbers in this one. And, the way this is created here is with these counter-rotating squares at a 45 degree angles. And, we've got one 1-inch square in the center. So that's going to be our unit square, unit 1 square. And then we're going to have this square here is rotated. So it's going to be the root 2 measurement. And then we've got the root 4. I put in all the roots, even though we don't normally say the square root of 4 is 2, but it's just interesting to see that progression of, the 2, 4, 8, 16, 32, 64. So it's doing this type of doubling sequence, the square roots of doubling. And, as we go, we've got the numerical values that are, especially the ones that we're not often used to seeing, like the 11.313 for this whole length here. So anyway, those are some of the numbers going to work with. And in my other video, what I did was I devised a way to construct the arc of the spiral out of a series of successive arcs that were planted, on the interior of the square edges, and then you do your arc with your compass. I show you in detail how to draw that in the other video, and then that little segment will be part of this circle, and it connects from this point, a corner of the square, and goes over to this point of the square. And as you do these sweeping arcs, a number of them, as you go around, you'll produce the whole Krystal Spiral. Now, some people, watching this might realize that, well, this spiral in nature is starting from a continually expanding radius rather than being these sweeping little arcs. But at least in the sacred geometry on the 2D plane with the compass, this is one way to draw it. And when I did that, I realized back in the other video, just one portion of this, that as we go along, we come up with one circle within here that was root 5. And that's an important number because it relates to the phi ratio. So this morning I was working with some of these numbers and I started to calculate, of course, all the other numbers for all the squares and all the circles as they expand out here. And, I put in, most of these are going to be multiples of square root of 5 and 10. All of them are going to be multiples of that. But once again, I decided to do the full, root 20, which is 2 times the square root of 5, root 40, root 80. But as you go, this is going to follow a doubling sequence as well. Each of these circles, as they expand, are going to be continuing on in that doubling sequence. So we've got the spiral, and it's just, touching a little portion of each of these circles as it goes along, and we can continue that on and on and on. All right, so I'm going to take these two sets of numbers, and I'm going to mishmash them and jam them together here in this image, and it's going to look totally confusing, and we're just going to be here for a minute, but that's me just laying over both the images and looking at the numbers. But there's going to be a pattern here that emerges in just a minute. So I'm going to show you how the phi ratio is continually showing up throughout this construction of how I went about doing it here. So first of all, let's just take away the drawing for a minute and just look at the numbers and how they're kind of paired together. So we're going to start with our 1 inch square connected to that root 5 2.236 circle. And then the next one in line would be the root 2, the 1.41. That's connected to the route 10. The root 4, the 2 inch square is connected to the root 5 times 2. And all those just I laid out so they would go over top of one another as we went along. These two additional square roots, 640 and 1280 here, they would be showing up later on in the sequence. So, you know, just following these simple mathematics here, I was able to just discover what those measurements would be. So, okay, here's where the phi ratio comes into all this. Because right now you're probably looking at a lot of numbers wondering what this is all about. So back in the previous video, so here's the follow-up on this video. When I was you know, discovering the drawing method and figuring out how it would work out with these half arcs, what are these little segments of an arc here, I saw that the 1 inch square here in relationship to the root 5 circle here, when you go from the top of the circle to the top of the square, so these between these two blue lines here is 0.618. And then of course, when you have the 1 inch square in addition to that, then you have 1.618, and that's phi. So, you know, the formula for phi is square root of 5 plus 1 divided by 2 will equal 1.618. And within this diagram, at that point, I only stopped there. I didn't really realize that, well, if it's showing up here, that it would show up through every circle and square relationship throughout the whole image, meaning that the whole crystal spiral is made up of phi ratio relationship between the squares and the circles. As you continue on, it will continue to show up at these lengths. So I've removed that from this segment here, from this drawing here, just to show you, once again, just looking at the circle by itself, that is root 5. You have the square in the middle, so that's the 1 inch, and that square is going to divide this line in half. And this is a simple drawing that geometers have drawn for ages, where they just plant their compass needle here, they bring it up to a corner, and they make an arc all the way around, and that gives you 1.618 from this length all the way to here. So, you know, the definition here of the golden ratio is a line divided by the golden ratio will always demonstrate a ratio where the whole segment, so that's A and B together, this whole segment, to that of the longer segment, which is A, is equal to the ratio of the longer segment, which is A, to the shorter segment, which is B. All right, so when you divide, for instance, the whole length, take that number and you're going to divide it by A, that will give you 1.618. When then you take A and divide it by B, that will also give you 1.618. And it doesn't really matter what the numbers are. You don't have to deal with just 1 and 1.618 to do that. Any line, whatever the length of the measurement is, as long as you find that dividing section, it will, when those two numbers are divided, whatever the numbers are, as long as they're at the divine proportion, the golden cut, it's going to produce 1.618, and an infinite number that continues on and on and on as an irrational number. So, well, then this morning I was deciding to, let's just go ahead and do this for a couple of these examples. And I pulled these right out from the original Krystal Spiral. And this is just pieces of it because, so here's our first one here, which is the 1 inch square that we were working with. and then we've got 1.618, and there's the formula. So I said, okay, let's do this with the next one in line. So here's my rotated square, which is going to have the length of 1.414 root 2. And I've got that same dividing line. And now I have the route root 10. And so I did the math on this one. So you take root 10 plus root 2 divided by 2 gives you 2.288 in a continual number. And you're like, well, what's that going to tell me? Because it's just a number. But if you divide it by the 1.414, which remember is the length of the square, then it will give you 1.618. And I know for some people who are into mathematics, this is like kind of pretty obvious that we're just going to be reproducing the divine cut over and over again in all these little things. But I didn't really realize it was contained in the Krystal Spiral, that it was going to continue to show up over and over again. So it's just leading me along a path of discovery. And I'm thankful to be able to share some of these insights, which then become totally obvious after I've worked on deciphering this for weeks or months and years at a time. So here's the 2.288 measurement. So that's from here, plus this addition, which is the 0.874, right? So the other way you can go about getting this measurement is take the whole length of root 10 and subtract the root 2 measurement, which is this square in the middle. So subtract root 10 from root 2. And then what you'll be left over with is the length of both these sides, and then divide that by 2, and then that will give you the smaller length. So then you can divide that length by 1.414, and that, of course, because the greater to the smaller are also in proportion as the whole length is to the greater, then that will also give you 1.618. So just a few more examples. I didn't do all of them. We just went through these, and there's no point in really reiterating this over and over again. But just with the next one, you'll see I'm dealing with square root of 5 times 2. So now I've got this whole length, right? And then we've got the 2-inch square, which of course is all these numbers are essentially doubled here, because once you double the 0.618 of the 1-inch square that we were working with, that will give you 1.236. And similarly here, when you double 1.618, it gives you the 3.236. But so this is just going to reproduce the phi ratio at another level, the next level up. You see that these squares are rotating back and forth here. It almost looks like they're kind of, maybe going to the right. I don't really know which way they could be going, left or right. But when you look at the spiral as it arcs around, you would see that the spiral itself is kind of following a progression. 45 keeps going around until it gets back again. So here at this last one, we're kind of halfway through the place where it will turn back to the upright position. So we've got a succession of 5 steps here. Here's another one with root 10, same mathematics. You can just pause the video and plug some of these numbers in and test them out yourself. You won't find any discrepancy in what's presented here because the numbers aren't really lying. And the beauty of this is that it's matching the geometry. Each of these are like, isolated situations here. It's just a square within a circle. Like I said, a classic drawing in geometry will show you, any sacred geometry book, most of them will show you the square on a line and drawing a circle around that, how to get the phi ratio. When you put them all together, though, and I won't continue on with all these mathematics because I think you're going to get the point. We're going to continue to do this and get 1.618 all the way through. So when you put them together, though, that's when we start to get a complete picture of what do all these little circles and squares that I've drawn here, what are they actually, showing us? And what they produce when we follow the edges of the line segments, as the crystal spiral has shown us how to connect these dots along the edges to produce this spiral, then this is what we're going to get of the crystal spiral, catching these segments of either a root 5 or a root 10 circle that is a multiple of it, you know, in a doubling sequence. So the doubling sequence is not only happening for the squares, it's also happening for the circles that are around them. And, you know, you won't really discover this unless you're doing what it is that I'm doing with putting a whole complete circle around those, because you'll see that these points along here, you know, catch all the edges of the other squares. So they're kind of meant to be, they can be drawn as full circles. And when you draw it as the full circle rather than focused on just the small part, then we see a larger pattern emerging here. And, you know, I decided to do this with the full circle because I was inspired by Vladimir Nabokov's spirals of the phi spiral and the Fibonacci spirals, how he drew that of the connected circles. So I said, let's try that with this crystal spiral and see what comes up. And that's how I made the discovery that these are route 10 and route 5, root 10 and root 5 circles, and how they fit into the larger rotating squares. I just really thought was very elegant and beautiful mathematics represented in how the geometry is linked. And now I see it's all linked to phi. So it's just really a pretty cool discovery for me. So here I am back. I just changed that whole drawing that we were just looking at. I changed it all to blue here just to show that, you know, I'm just looking at a small segment of this. And when I drop it back into the larger pattern that we started off with, minus all the numbers, we'll see that that, you know, is going to line up and fit over top of the previous drawing, which will continue to expand outward. So, you know, just knowing that the phi ratio is embedded in this whole design is interesting to ponder, because there's been some difficulties with the phi ratio from the crystal spiral folks' relationship to it. So just to see that it's in this is interesting. I find this to be another one of these really unifying videos that sees it from another perspective and see how it all is linked together, and that even in the predominant symbol of one of the predominant symbols of the Cathara grid crystal spiral information being this spiral, seeing that these mathematics of phi show up into it really does, in my mind, connect and unite some of these polarized views, and the math and the geometry itself seems to be presenting that. So I'm looking forward to other people who are well versed on either end of this, what they have to say about what it is I'm presenting here. So anyway, I just rotated the whole image back to the an angle here, and you know, this essentially is the classic image of this square and the large circle with the line, minus what we normally see. We never draw the rest of this material inside the circle here, all these other squares and circles. But if we did, we would be creating this crystal spiral arc that would kind of rotate around. So here it is once again, you know, the A plus B is to the A as the A is to B. And no matter the length of the line, when we divide the larger by the smaller, we are going to come up with 1.618 repeatedly over and over. And that number is just entirely embedded within the whole framework of this square and circle relationship here that I've presented. So yeah, that's it. I hope you enjoyed that quick video. Just wanted to kind of get that out before I moved on to some other things. I was working on the book that I'm working on this morning, and just finally got to the crystal spiral stuff. And then I revisited all that and started making these discoveries. So I'm grateful to have opportunity to share with all of you, and I hope it adds to some interesting conversation and discussion. And till next time, much love and have a great rest of the day.